Hello everyone, my name is Victor. I am a researcher at Zup Innovation from Brazil. I am glad to introduce our research toward a definition of cognitive-driven development. My presentation is closed in 6 parts: context and problem, motivation, cognitive-driven development, guidelines to use CDD, including an illustrative example, some discussions and future perspectives. Let's start with context and problem. In the software life cycle, it's expected that its features will be changed and new one will be incorporated to solve better some problems. In this way, the increase of the software complexity is natural. Many times, when the developers need to refactor some code or fix some faults, they are weighted by unpredicted complexities demanding software. At that moment, a question arises: why does this class have more than 1,000 lines of code, or why no one split better the responsibilities? The main problem in this scenario is that to manage the complexity, a strategy must be employed. However, the programming is more focused in solving business problems. As a result, at any moment, the developers will be affected by cognitive overload. Based on this context, there is a lack of empirical studies investigating how the source code could be developed under human cognition perspective. Most studies in such field explore this approach to evaluate the code at its understanding level. The complexity surrounding software impacts its maintenance and evolution, but the understanding cannot follow in the same proportion of this continuous expansion. If the understanding is very important for the software, how to provide a high quality application if we cannot deal efficiently with their complexity? Considering such challenges, what needs to change in the way of producing software? Several practices are widely adopted in the industry to make the software design more understandable, flexible, and maintainable, but elements with low cohesion and efficient separation of responsibilities continue being produced and reside in the final releases. So we have a suggestion to keep on simplicity at the same time define a feasible limit for the software complexity based on human cognition. Based on this idea, we formulated the cognitive-driven development principles, taking account cognitive load theory and cognitive complexity measurement. We found in the cognitive psychology field some studies highlighting the Sweller's works about the recognition of a human limitation to deal with a high number of items in our short-term memory, and that there is an intrinsic complexity for materials. Problems that require a large number of items to be stored in short-term memory may contribute to excessive cognitive load. Experimental studies performed by Miller have suggested that humans are able to hold only 7 plus or minus 2 units of information in our short-term memory, an important work in the psychology area known as magic number 7. Regarding the cognitive complexity measurement, we realized that it would be necessary to define a relation among intrinsic complex points and software metrics. Recent studies in this field take into account basic contour structures and corresponding weights in terms of understanding effort. Based on Misal's work, some categories for the metrics were extended, as can be seen in this table. The goal here is only to provide a notion of how to calculate the intrinsic complex points from the source code. Here we have the following categories: branch, exception handling, coupling, and cross-cutting requirements. If and else have 2 points, strike at final 3 points. For each coupling between objects, the number of intrinsic complexity points can be increased. Finally, there is a category for cross-cutting features, code related to infrastructure logic that we decide not to score. We know that this code is not trivial, but they are less changed than the code related to business rules. Although research on CDD is in the early stage of evaluation, there are some essential properties as follows. CDD is complementary to other strategies like clean architecture, solid principles, and well-known practices. The main contribution of CDD is to guide a clear definition of frontiers for responsibilities. There is not a specific metric to follow the CDD. Therefore, any metric can be used. like lines of code or psychometric complexity. It's important to keep a limit for the number of intrinsic complexity points. The project's nature and experience level of developers can be considered to define a limit. We believe that CDD walks in the direction of reducing the cognitive load for developers. After all, people with different experience level will handle code with a balanced level of complexity. As we can see, here we have a figure showing an illustrative example of the application of our method. This class, called New Payment Controller, has several control structures, and from a rapid analysis, we can identify 6 contextual couplings, that is, dependencies with other classes available inside the project. There's a function as an argument and a if statement. As a result, we have a total of 8 intrinsic complexity points. It's very easy to measure this number considering branches of the code and conditional structures and so on. The most important here is that developers can define a feasible limit to guide the creation of new classes and how to factor in the complex implementation units. It's a way to reduce the cognitive overload for the developers even with the continual expansion of the application. As an evolution of our work, we intend to explore the following aspects. To develop a plugin for IntelliJ to estimate the intrinsic complexity points during programming, we believe that CDD practice can be disseminated in the industry with a supported tool. For instance, a team with different experience levels can define a feasible limit, and since the beginning of the project, the classes can live under this rule. We also intend to perform a study involving the CDD effects for different quality metrics as a reduction of the number of faults. Thank you so much for your attention. If you have any doubt, feel free to contact by email.